Hello folks, we're back with the next part of the video. That is, we were doing the problem number 13, that huge one, where we were taking up the intervals and analyzing how the function is. Now we are taking up the next problem. This problem is a good problem. It's an application-based problem on increasing, decreasing, how you apply that. It's really good. Unless you have the concept clear, we are not able to get it like through. Question says that the function is x squared plus ax plus 1 and it is strictly increasing on 1 2. They've told us that it is increasing on 1 2. If that is the case, then they ask us to find out the least value of a. So every time it is like they give us a function and we decide the interval, we find out the interval where it is increasing, decreasing and so on. It's just the opposite. They give us the interval and they give us the increasing part also. They ask us to find out an unknown value. That's it. So that's how our working is going to be. So anyhow, we know because it is increasing, we have to work with the derivatives. So let's go to the derivative right away and find out what the derivative is, f dash x. F dash x for this, x squared, we all know derivative is 2x. A, it's a constant, so derivative of x is 1. And 1, because it's a constant, no derivative. So finally, your derivative is 2x plus a. That's it. Now, we are very clear about the fact that the function is increasing on the interval 1, 2. So that means f dash x is positive. So that's a huge data, right? So it's clear to us that here f dash x is positive on 1, 2, right? So let's, our work is going to be on that. So we know that since we are on 1, 2, our x is taking the values between 1 and 2. That's clear to us. So let's start with that data and see whether we are able to reach. So x is between 1 and 2. We have to get a function of the type 2x plus a so that we can decide or we can use that it is increasing. So let's get this 2x plus a from here. For that, let's multiply throughout this equation by 2. So when you multiply by 2, 1 into 2 becomes 2. This becomes 2x. 2 into 2 becomes 4. So you're getting the inequation now 2 less than 2x less than 4. Since we are always looking on getting, we have to get that f dash x means finally you have to get 2x plus a. So let's add a on all the parts. So you'll get 2 plus a, 2x plus a and 4 plus a. So indirectly we have that our f dash x on this is lying between 2 plus a and 4 plus a. So that's clear to us. F dash a is positive. F dash x is positive, right? Because it's increasing. So automatically the bounds have to be positive. The upper and lower bound have to be positive because f dash at x every point is positive. So therefore, so that's the turning point, since f dash x is positive on 1, 2, not everywhere, only on this interval. So therefore automatically the bounds have to be positive. So therefore what will happen? You will have 2 plus a to be positive and 4 plus a to be positive. If 2 plus a is positive, what's the value of a? A is greater than minus 2. And if they say if a plus 4 is positive, then a is a value greater than minus 4. So then since they are asking us, I think in the question they ask us, what's the least value of a for which you will have this increasing and all that. So for that, find the least value of a for which. So therefore we will take the value of a as minus 2. A greater than minus 2. It is for that value that, because it has to satisfy both the conditions, a greater than minus 4 and a greater than minus 2. So if it is a greater than minus 2, definitely it will satisfy both the conditions. So that is why a greater than minus 2 is the, that means minus 2 is the least value of a for which this will be increasing. So you can have that conclusion done. I'll just look at the question as to what they are asking. Find the least value of a so that the function, the required least value or something like that, you can say the required least value or the least value of a is, I can write like that, the required value is minus 2, or you can say the required least value is minus 2, is minus 2, or the least value of a which will make and all that, that way. So that's how it is. the turning point is here, where you have to, judge that because the function is increasing, the bounds have to be positive. And if the bounds have to be positive, how do you figure it out? So this is how happens. You're getting both the values. So it's enough in equations, exactly we do that. You include one value so that both the values will be included. If you only include a greater than -4, there are many values which will not suit both ways. So that is why you're taking values a greater than -2. So that will suit all the values. So that's how it is. Now we can take up the next question, question number 15. So question number 15 says that you are having f of x as x plus 1 by x. Function is quite simple. And they say that you take an interval, they say let I be an interval disjoint from -1, 1. So the interval I that you're taking, it is not -1, 1. So rather it is real number minus -1, 1. Now that's your interval. So from the entire, if you want to understand it better, from the entire real number line, you remove this. Don't take this, and you can take the entire other part. Everything is included. That's the meaning. So you have to show, what do we have to show? You've got to show that this is increasing. It's strictly increasing on I. You have to show. Anyhow, increasing means derivative is obvious. So let's find f dash x. So f dash x means it is the derivative of x, it's 1, and this is like x raised to -1, nx raised to n minus 1. So -1 by x squared. So this is f dash x. Now it's okay. Take one value here, check. Take a value here, check. So for x belonging to say -infinity to -1, something like -2. So what will happen? Therefore f dash at -2, if you were checking, how will that be? It will be like 1 minus 1 by 4, it's positive. Yeah, because it's 3 by 4, which is positive. So also you can take one value here, same way. You can take 2 or something, f of 2 if you want, or 10 or something like that. Same way, 1 minus 1 by 4, which is also positive. Now, so on. You can take any values. It is going to be positive. So therefore, we can say that therefore f dash x is positive on I. So f of x is increasing on I. I is the interval as it's being shown here. That's it. That's what they ask us. That show that it's strictly increasing. You'll write strictly increasing on I. That's about it. So that's what happens there. If you want, you can be a little particular because they have said strictly. So this is what happens, that f of x is strictly increasing on I. They have asked us to show that it is strictly increasing on I. That's all about it. As usual, you should be popularizing the channel by speaking about the channel to your friends also. Thank you.